students, and welcome to today's lesson. I'm Miss Lee. Today we will continue to investigate the question, what can change an object's motion? Are you ready? Grab your pencil and your science journal, and let's get started. Whoa, look at this photograph. What is the object in this photograph? Let's look more closely. What do you notice? I noticed that the cups are attached to two sides of a block, and the block is at rest on top of a table. Do you notice anything else? Oh, look, pencils are taped to the edges of the table. What do you wonder? I wonder why are cups tied to the block, and how could we make the block move? I wonder what will happen to the block if we add something to the cups. Do you think the block will move? These objects, when used together in this way, are called an Atwood machine. How do you think we could use an Atwood machine to investigate the question, what can change an object's motion? Today we'll explore how different forces affect the motion of the block in an Atwood machine. But before we start, let's look at our anchor chart and think about what we've already learned about forces in motion. Hey, wait! We don't have a section about forces on our chart yet. Let's add one. What new information can we add about forces? Let's add forces are pushes and pulls with strength and direction. Also, forces can change the speed or direction of an object's motion. Let's also update the title at the top so that it now says Forces in Motion. Your first task for today will be to update the anchor chart. All right, back to our Atwood machine. Look at the block. Right now, the block is at rest. How could we make the block move to the right? How about to the left? Could we make the block move without touching it? Oh, look at the cups. They are attached to each side of the block. Do you think we could add something to the cups to move the block? I have these pennies. Do you think we could use them? Yes, maybe if we put pennies in the cup on the left or right side of the block, we could make the block move to the left or to the right. Adding pennies to one of the cups increases the strength of the force exerted on that side. As we work with the Atwood machine, we will use pennies to change the strength of the force exerted on the block. First, let's focus on moving the block to the right. I've taken the cup on the left side of the block off for now. We will add different numbers of pennies to the cup on the right and see what happens. As you watch this video clip, I want you to focus on the direction the block moves and the number of pennies that I placed in the cup. Are you ready to see what happens? Let's watch. 1, 2, 3, 4, 5. Interesting. What do you notice? I noticed that the block does not move much when just 1 or 2 pennies are placed in the cup. But when we add more pennies, the block starts to slide to the right edge of the table. So, what caused the block's motion to change? Now is a good time to make a model. To help us organize our thinking and show what we saw in the video clip, let's start by drawing all the components of the system. What do we need to draw? Well, we need the table and the block, right? What else? A string connects the block to the cup. Great. Okay, now think about the video clip. When does the block start to slide? I noticed that the block doesn't slide until we put 5 pennies into the cup. The pennies exert a force on the cup. Since the cup is attached to the string, the cup also exerts a force on the string. What is the string attached to? The block. So the string exerts a force on the block, which causes the block to move to the right. We can write pull from string on the model to explain the force on the block from the string. We can also add an arrow to show the direction of the force exerted on the block by the string. Let's add another arrow to show the direction of the block's motion. We now have a force model, which is a model that uses arrows to represent the strength and direction of the forces acting on an object. I wonder what will happen if we remove the right cup and attach a cup with pennies to the left side of the block. Which way do you think the block will move? Point in the direction that the block will move this time. Okay, here's a force model of the Atwood machine with a cup on the left side. What would cause the block to move? Will the block move with nothing in the cup? No. We have to add pennies to the cup. Just like when the cup was on the right side, the pennies exert a force on the cup exerts a force on the string, and the string exerts a force on the block. But this time, the pull from the string moves the block to the left. Let's look at both models side by side. What do you notice? Oh, do you notice that the force arrows and the motion arrows point in the same direction on each force model? The direction of the force exerted on a block affects the direction that the block moves. So we know the force exerted by the pennies affects the direction of motion. Do you think that force can also affect speed? Remember, speed is the distance an object moves in a certain amount of time. Let's watch 2 more video clips. In this video clip, I put 6 pennies in the cup. And in this video clip, I put 12 pennies in the cup. Which block do you think will move faster to the edge of the table? The block attached to the cup with more pennies or the block attached to the cup with fewer pennies? Shout out your prediction. Let's watch. The cup with 6 pennies took 3 seconds to pull the block to the edge of the table. The cup with 12 pennies only took 1 second. Wow, did you expect that to happen? 12 pennies exerts a stronger force than 6 pennies, so the block attached to the cup with 12 pennies moved to the edge of the table faster. So what is the relationship between the speed of the block and the force exerted on the block? When a force is exerted on an object, the speed of the object depends on the strength of the force. In other words, a stronger force results in an object moving faster, and a weaker force results in an object moving slower. Our Atwood machine investigation reminds me of the toy wagon we observed from a previous lesson. We saw the motion of the toy wagon change as the wagon was pushed and pulled by our virtual student, Michael. Remember, pushes and pulls are forces. Today we explored pulls on the Atwood machine, but what about pushes? Did we use any pushes? I wonder, how do pushes and pulls compare? What is similar about them? Your second task for today will be to answer these questions. You know what? I had so much fun exploring how forces affect an object's motion with the Atwood machine. I can't wait for our next lesson where we'll explore more than one force acting on an object. Let's review your tasks for today. First, fill in the blanks to update the anchor chart. Second, answer the questions about pushes and pulls.